Using OpenStax Textbook Calculus Volume 2, we are working in Section 3.1 on integration techniques. And we've done integration by parts. We've done a problem with integration by parts that you had to do more than once. And now we're going to talk about definite integrals. If you remember, definite integrals are when you have upper and lower bounds that you have to follow, and you plug them in and get a numeric answer, as long as your a and b are numbers. So my functions have to be continuous or have continuous derivatives on the closed interval from a to b. So you still do your uv minus v du, or integral v du, but you evaluate your ub from b to a, and then you do your integral v du from b or from a to b. Sorry, I kept saying it backwards. Find the area of the region bounded above by the graph of y equals inverse tan x and below by the x-axis over the interval from 0 to 1. So we know we're looking 0 to 1 of, technically we're doing inverse tan x minus 0, because that's the x-axis, dx. Well, inverse tan x. Sorry, I'm trying to get my notebook turned. If we were to look at this, the graph comes across like this, and we're looking from here to here, and we want the area. So for this, we're going to say u is inverse tan x, and v, or dv, sorry, is dx. The reason we're doing this is we don't have a rule to integrate inverse tan. We have a derivative rule for inverse tan. We do not have an integration rule for inverse tan. So du, if we follow the rule for arctan, is u prime, which is 1 because we're using x, so 1 over 1 plus x squared dx, and v is x. So integrate, nope, uv, so inverse tan times x from 0 to 1 minus the integral from 0 to 1 of v times du. If I integrate inverse tan, or sorry, if I evaluate inverse tan from 0 to 1, we'll get an answer for that in a few minutes. What we're going to look at right now is this bad boy right here. So if I have x over 1 plus x squared, I'm going to put my dx up there as well. If I say u is 1 plus x squared and du is 2x dx, I would put a 2 here and a 1/2 out here. And that would be 1/2 natural log absolute value of u from 0 to 1. So we have x inverse tan x from 0 to 1 minus this one right here. And when I plug it all in, we're just going to go straight into the calculator, I guess. We end up with pi over 4 minus, we're not going to use the calculator, 1/2 ln 2. If we put it in the calculator, end up with a decimal that's approximately 0.4388. But this is the really pretty answer. All right, finding a volume of revolution. Find the volume of a solid obtained by revolving the region bounded by the graph of f of x equals e to the negative x, the x-axis, the y-axis, and the line x equals 1 about the y-axis. So let's think about this graph first. E to the negative x at 1 comes down like this. Okay? Technically, it keeps on going, but we're not doing that because we have to make a bound here. So we're bounded by that, the y-axis, the x-axis, and the line x equals 1. So this is the region, and we are going to revolve around the y-axis, so I'm going to draw a mirror of that region on the other side. And technically it revolves around this way. So we have this. And the top part is like a cone almost. We're going to use the shell method to find the volume of this. So we're going to end up with our integration from 0 to 1 of 2 pi x e to the negative x dx. Okay? So our 2 pi is going to come out front. Let's rewrite. Integral 0 to 1 of x e to the negative x dx. U is going to equal x. dv is going to equal e to the negative x dx. du is going to be dx. And v is going to be the integral of e to the x, or e to the u is e to the u. So this is e to the negative x. We have to have a negative on there because we negative 1. Negative 1. Okay, we got it. Sorry, my brain is working overtime. So it's negative e to the negative x. So 2 pi times u v minus the integral v du. Oh, and this is from 0 to 1. 0 to 1. So v is negative, which is going to make that a plus, e to the negative x, du, which is dx. All right. From here, we end up with negative 2 pi x e to the negative x from 0 to 1 minus, because we end up with a negative 1 here, 2 pi e to the negative x from 0 to 1. And that gives us 2 pi minus 4 pi over e. And we would end up with approximately 1.6603 as our calculated volume.